you'll see I've created a container already there for images called CDN images. Expand that out, and you can see I have a whole bunch of. As we move into the various storage and database services available to us when we're building applications and utilizing public clouds such as Azure, we first need to understand the different data types available. And there are three primarily that we're going to go into, which are structured data, semi-structured data, and unstructured data. And just by reading them, it kind of makes sense to some degree, but let's dive into them in a little bit more detail. Well, first of all, we have structured data. So this adheres to a schema. All the data has the same field or properties. So for example, it's stored in a database table with rows and columns, things you're pretty familiar with like in SQL, and it relies on keys to indicate how one row in a table relates to data in another row of another table. You've probably been familiar with like primary keys, etc., that you use in SQL to kind of connect different data sets, and it's referred to as relational data as well, also known as a relational database when you're thinking of, say, SQL. If we move on to semi-structured data, a little bit different here. Semi-structured data doesn't fit neatly into tables, rows, and columns. You basically are using things like tags or keys to organize and provide your own hierarchy for the data. And this is often referred to as NoSQL or non-relational data. If we move on to unstructured data, this is pretty much what it is. No designated structure whatsoever, no restrictions on the kinds of data it can hold. Good example, blob storage. It can hold PDFs, JPEG, JSON, videos, put whatever you want up there, Word docs, Excel, etc. It's just objects you're thrown into an object store at this point. And the big thing about this is enterprises are struggling to manage and tap into the insights from all of their unstructured data. I've worked with a lot of customers in the financial industry, worked with a lot of customers in the medical industry, and they just have a breadth of data there, and sometimes it's like a gold mine to them if they can just tap into all this data they have, connect it all together. They can draw insights from that data and starts to help them make good business decisions. So that's the big challenge, all of these different types of data. Now, what are the right services and storage types that you need to use when you're doing various applications? Let's now take a look at Azure SQL Services, also known as Structured Query Language. If you're not too familiar with SQL, it's been the primary database methodology for a while. This is our relational database methodology, and typically, your DB admins in any enterprise will understand, SQL as they will often call it. So we have Azure SQL to begin with. This is our relational database as a service. So instead of you having to build a virtual machine and then install SQL Server on top of that machine, on top of Windows, although there are Linux versions available now as well, this is provided to you as a service. It essentially uses the latest stable version of Microsoft SQL, and you can create new servers, or you can actually migrate existing databases from, say, IaaS SQL, SQL that you might have on premises running on physical servers. You can migrate that into Azure SQL using the Microsoft Data Migration Assistant. Now, there are some key features of Azure SQL Database you should be aware of. Well, one, predictable performance, and it's measured in database throughput units, also known as DTUs. That's how you often build, and also how the performance is measured for SQL. High compatibility, supports existing SQL client applications. The only thing I would say on that, there are sometimes incompatibilities, and you'll learn more about SQL managed instances, another version of SQL that Microsoft's made available. But for the most part, it is highly compatible with existing SQL workloads. You just might have to tweak a few things. Sometimes there's some schema edits and things like that people have to do. And simplified management, I think this is the big thing. Not much to manage. Managing SQL servers on premises has been a very challenging and often expensive task over the years, and this really simplifies the management of that. Now, there are three tiers available. We have basic, standard, and premium. So basic is for small databases with a single concurrent user, small DBs, 5 DTU in size, small scale apps, dev test. Standard is for medium-sized databases that must support multiple concurrent connections. So it's a good option for cloud applications with multiple operations, workgroup or web apps, and 10 to 100 DTU. Premium, these are large databases that support large number of concurrent connections, so lots of people connecting simultaneously, high transaction, large users. We're in the 100 to 800 DTU here, and this is really mission critical applications when you're in this tier. Now we do have a new option in Azure, which is SQL Managed Instances. I say new because I didn't see them specifically called out on the exam, but Microsoft does say, not inclusive in their curriculum. But if we look at Azure SQL Managed Instances, just like Azure SQL, they are managed SQL servers, but a little bit different. These are basically trying to mimic SQL on premises or legacy SQL that you might just be running in a VM in the cloud. So they have higher compatibility with legacy workloads. So just be aware, people call this SQL MI for short. This might come up now and then now that it's gone GA, and a lot of people are moving towards it. There's a big fan base here because again, highly compatible, very easy to move into, works just like my SQL server that I'm already running my application in. Now in addition, there's some other third-party databases in Azure, some managed options. So for MySQL and PostgreSQL, they are managed options. When we say managed, they're managed, provided as a service. They've got built-in HA, predictable performance, pay-as-you-go, auto-scaling, all the things you would expect from a managed service in Azure, just not specifically SQL. This is MySQL and PostgreSQL that are available as well. And in addition, we have some non-managed options, so like Windows Azure VMs hosting MySQL installations, ClearDB, on Linux we have MySQL as well. Non-managed because essentially you're just buying something from the marketplace that has everything pre-installed, but you have to manage, that application, the patching, the maintenance, etc. for the underlying database engine there. It's not managed for you in Azure. So that's basically the Azure SQL type options in a nutshell. Azure SQL being the one you're likely to get the most questions around. It's definitely a direction Microsoft is pushing people when it comes to relational databases in the cloud. Let's now take a look at another database service that's become very, very popular in Azure, and that is Cosmos DB, which you've probably heard a lot about already. And well, what is Cosmos DB? Well, first of all, just helps to understand this is a globally distributed database service. It supports schemaless data, such as NoSQL, as we discussed in the data types, and it's used to build these highly responsive, always-on applications which have constantly changing data. So when I think of that, I think of, not to say that Facebook uses Cosmos, but Facebook is a good example of something global. Users all around the world are accessing it, they're changing data in it, but they probably want to access it more locally rather than everybody, say, coming all over the world and going to a US data center. Wouldn't make a lot of sense. Cosmos is a way for the database to be spread out around the globe, and there's some mechanisms to make sure that writes are consistent and the data, eventually gets synced across all those different services. Another example Microsoft gives on the Learn site is this image here. Developer frequently updates the catalog for an online training course catalog. That goes into Azure Cosmos DB. Global users and training developers, work against that Cosmos DB database. And again, they're distributed all over the world. If you want to see more of an architecture diagram of this is from the Cosmos DB site on documentation at Microsoft, and helps to think about it from the top here. So we've got mobile users, web browsers, other devices coming in through the internet. They might hit a traffic manager that tells the user, hey, you're going to go to West US, North Europe, or Southeast Asia. And then the good thing here is if you look at the services under there, might have a web tier, a middleware tier, much like normal applications today. They can use load balancers, etc. But those tiers then basically talk to Cosmos DB. So in this case, the web tier hits the middle tier. The middle tier is what's talking to the database. And in each region, you see it just talks to Cosmos DB and it thinks it's in its region. But then behind the scenes, Cosmos DB is taking care of all the replication. And this concept of allowing people to natively implement protocols for NoSQL APIs is a big benefit to this. Good examples of that are DocumentDB, MongoDB, Graph API, Tables API, etc. And this really allows the application to continue to remain portable and be vendor agnostic. And on top of that, again, everything is automatically partitioned for performance and storage capacity, in those various regions. So that's Cosmos DB in a nutshell, and really just know when to use it, and definitely dig into the Cosmos DB documentation on the Microsoft site if you want to know even more about it and get more into the weeds with it. There's a lot of good tutorials there that sort of guide you through it. Okay, so we understand a lot about different database services, but what about if we just want some information on Azure storage and some of the basic storage fundamental services that are available there? Well, to begin with, we have Azure Blob Storage, and Azure Blob Storage is really just unstructured storage for storing objects. Again, it's a big bucket that we just throw in our images, our videos, files of any type, basically. Use cases for Blob are streaming video and images direct to the user, backup DR of data, and things like archiving. On top of that, we have Azure File Services. So if we move on to Azure File Services, these give a lot of benefits if we want a file system that we want an easy way to create file shares. So contrast that with Blob Storage from a second ago. Blob Storage is just raw objects, images, videos, etc. A file share is really for Word documents, Excel, where we want to put like permissions and things like that on, much like we do today, probably in file shares that you have in your data center, and sometimes you ask IT to create a file share, or perhaps you admin those file shares today. That's the big difference here. They support SMB 2.1, which is unsecured, and 3.0, which is secured. You can mount them on Windows, Linux, or Mac. And Azure File Sync is a new service that's out, which can be utilized to sync file servers on premises with Azure Files. This is a really popular and welcome addition to Azure Files. Essentially, you can have your file share, on premises, and it syncs services up to Azure Files directly. So the file share that's actually in the cloud, and it's a good way, to make sure all your files are synced up, and can restore them to other file services around the globe as needed in the event something maybe even just happens to that file service. In addition, we've got table storage, also under the concept of storage accounts, which we'll hear a little bit more about later on. And table storage, you can see there, it's a no SQL key value store, schemaless design, structured or unstructured data can go in here, and you access this using the OData protocol and link queries, WCF data service.net libraries. So you can see it there, account, table, entity, object. That is the relationship from the storage account. You then create tables, you got your entities, and then you've got your objects, which could be like name, address, species, location, etc. So essentially just raw table storage for you there. And last but not least in the section, we have Azure Queue Storage, which is a service for storing large numbers of messages that can be accessed anywhere in the world. It's a reliable mechanism for storing and delivering messages for applications. It can be used to help build, flexible applications and separate functions, for better durability across very, very large workloads. Other thing to note is single queue message can be up to 64 kilobytes in size, and a queue can contain millions of messages up to the total capacity limit of a storage account. And again, you'll learn more about storage accounts, a little bit more detail, not as important the detail for the AZ900, but I think it helps to understand how they work. Particularly, if you're taking this exam for somebody, say, in the field, or you're an IT admin getting into cloud computing, definitely helps to really, really understand storage accounts. And so what you can see now, just flicking back through all these, you've got table storage, queue storage, file services, and blob storage. All of these come under storage accounts, which you'll learn more about later. But at a high level, blob is for, unstructured data, just throwing it in buckets there. We've got file services for storing files that we would typically want to put permissions on. We've got table storage for raw table storage, schemaless design, and we've got queue storage for storing and delivering messages for applications. So a wide range of just core storage services available to you there. One of the most important things to understand when you're managing your virtual machines are the different storage types that you can connect to your virtual machine. And we'll start off at the beginning with the lowest price, but the one that's really just backed by traditional HDD, which is the standard storage, standard HDD storage to be more specific. It's the most cost effective, but the throughput and IOPS, you don't get very high maximums there. They're based completely on the throughput of the VM itself and aren't guaranteed from a performance aspect. When you move up though, you get into standard SSD. Everybody today hopefully knows about SSD drives, certainly a lot quieter, but more importantly, you just get much better throughput, much better IOPS per disk, and these are the ones that they recommend now for most workloads that you provision in Azure. Moving up, you still have premium storage. Premium storage actually came out before standard SSD, and then they released this lower SSD storage as standard SSD, but premium SSD storage still exists, and it's backed by SSD drives, highest performance, lowest latency, max throughput 750 megabytes a second per disk, and max IOPS 7500 IOPS per disk. If we look at these more individually, you'll see there's various SKU sizes. So if you start with the standard disks at 32 gig, you've got an S4 going all the way up to S50 at 4095 gig, or 4 terabyte disks essentially you can add there. Again, the IOPS throughput depend on the VM itself, and essentially as soon as you go above like 32 gig from the S4, when you hit the 33, you suddenly start paying the S6 SKU price for that. Moving on, we've got standard SSD storage sizes. So here we move into the E series of disks. So they have SKUs associated with them as well. 32 gig up to 4 terabytes. Max IOPS though, you can see 120 for the E4. E6 goes up to 240. Then we hit 500 throughout from E10 up to E50. When we look at throughput, again 25 megabytes a second on the E4, 50 megabytes a second on the E6, and then once we hit the E10, we're at 60 all the way up. Premium SSDs, a little bit different as well. P4 through P50, 32 through 4 terabytes. As you can see there, so it's 32 gig, sorry, through to 4 terabytes. And then max IOPS 120, 240, 500. Then it starts to jump 1100, 2300, all the way up to 7500 on the P50. Max throughput again increasing throughout as well, and once you hit the P40 you sort of level out around 250 megabytes a second. Now Microsoft does have Ultra SSD in preview right now, and this allows us, based on disk size 4, 8, 16, see a little bit different here as we go up, but you can see massive IOPS increases, a lot of throughput increases. So at the time of recording they shouldn't be on the exam. It's worth noting because things change very, very quickly. Services go GA very quickly. Once they hit the public preview, it's not long before they go GA. So definitely just be aware that these exist as well. Now, when it comes to these, you'll also see when you sort of pull up the Microsoft website, the concept of these higher size disks as well. And so they increase in increments of 1 terabyte, and the IOPS you can see is capped at 160,000, and throughput is capped at 2,000 megabytes a second as well. And you'll see now that there are other disks for premium and standard SSD as well that go beyond the sizes that you've seen, just in the tables that I've shown you here. So definitely just check on the latest sizes because they are constantly being updated. Now, one thing to keep in mind are the VM limits. Just because you picked a size does not mean that your VM can handle it. So make sure that your VM can handle your bandwidth. Otherwise, even though you've associated a disk with high throughput, high IOPS, it is constrained to lower values on the virtual machine. That's the same with networking as well. The VM is going to have network limits, the VM has storage limits, and you need to make sure that just because you associated this very high performing disk, is my VM SKU able to handle that as well. Perhaps I chose a D2, now I need to move up to a D4 instance in order to accommodate that. Next, we need to look at things like managed versus unmanaged disks. So just because we picked our disk, we also decide how we want to associate it. You probably saw in the demo, we pretty much use managed disks throughout now, but it is important to understand the difference. Unmanaged disks are your DIY option. You have to manage the storage account and decide, when am I going to reach my limits, etc. You've got to piece everything together. It does have this overhead essentially because you have a 20,000 IOPS per storage account limit that you have to then deal with. However, it does support all replication modes: LRS, ZRS, GRS, and RA/GRS. Managed disks, by contrast, are the simplest option. You don't have to worry about the storage account. We don't care about management overhead. Microsoft is going to manage all of that for us. However, it only supports LRS replication mode currently. Now you may be saying, okay, that's a huge limitation because I need to be on GRS, I need geographic replicated storage. What about in the event of a disaster recovery? Well, the good thing to notice, and we talk about Azure Backup in a different module, you can back up your VMs to GRS and then you could restore them anywhere else. Not quite the same thing as having the disk, readily available, but if it's backed up to GRS, depending on your RPO, RTO requirements that you have for backup and disaster recovery, that could be a safe option for you. But I would always, if possible, choose managed disks. It's much, much easier to handle. Now, speaking of those replication options, let's take a look at them. Well, we have locally replicated storage, LRS. This is replicated 3 times within a storage scale unit. And a storage scale unit is a collection of racks of storage nodes. They're hosted in the same data center in the region that your storage account was created. Then we have ZRS. This is zone replicated storage, replicated 3 times across 1 or 2 data centers, in addition to storing 3 replicas similar to LRS. We have geographically replicated storage, GRS, replicates your data to a second region that is hundreds of miles away from the primary region. Your data is curable even in the event of a complete region outage. So that's what access. You can access the replicated storage at the other region. You can't write to it, but you can read from it if you want to as well. Now let's sort of summarize these out. So again, if we look at LRS, data replicated across multiple data centers, no. Data can be read from a secondary location, no. Number of copies, 3. So ZRS, 3 again, but it's replicated across multiple data centers. GRS, 6 copies of the data replicated across multiple data centers in multiple regions, if you recall. And then RAGRS, exactly the same as GRS, but now we can read the data from a secondary location and the primary location as well. So definitely understand these if you're heading for your Azure certification. Let's get started with blob storage by taking a look at this from the storage account perspective. First of all, we have our storage account, and you'll need one that supports blob storage. In addition, we have our containers, which are inside our storage account. This helps us organize our various blobs and images and data files as we come across them. And finally, we have our blobs themselves, which go inside there. Now, you may be thinking, okay, what is a blob? How is this different? Well, blob is a binary large object. Think of it as your ones and zeros. These could be images, video files, random text files, or whatever they might be, but don't confuse them with files compared to like an SMB file share, for example, which has permissions and other things associated directly from a CIFS perspective. This is for storing large amounts of images, videos, etc. Now, if we look at the storage account types, we have 3 major types. We have GPV version 1, blob accounts, and GPV version 2. Now, GPV version 2 is the main choice you will use when you create storage accounts in Azure now, because it allows us to do page blobs, block blobs, so we can do all of our images, videos. We can also store VM disks in there as well. We can mix everything in a GPV2 account. GPV1 allowed us to store blobs and other disks as well, but a blob account was specific only for blob storage, and ultimately it was confusing for everybody, so that's going away, and GPV2 accounts are ultimately the direction going forward. You may be asking then, okay, well, what is the difference between a block blob and a page blob? So a block blob, again, is ideal for storing text or binary files. Again, those are those images and video files. A single block blob can contain up to 50,000 blocks of up to 100 meg each for a total size of 4.75 terabytes. So that's a single image, ultimately could be 4.75 terabytes. Append blobs are also there, and they're optimized for append operations, example for login. Now, you may see that difference between blob creation and append blobs, and that's just important from that perspective. Page blobs, on the flip side, these are for read-write operations. Think of your VM disks here. These are used by Azure VMs, and these can be up to 8 terabytes in size. Which leads us on to the next thing that we need to cover, which are storage tiers. We've decided now that we want to use blob storage and store a bunch of images, but what's the right tier to go for? Well, the first one we look at is hot storage. This has our highest storage costs, but our lowest access costs. So think of this for frequently accessed images that we might be utilizing in our application, or maybe website content, things like that, accessed very periodically. Then we have cold storage. This has lower storage costs now, but higher access costs, and it is possible to move from cold to hot and hot to cold, as you'll see in some of the demos. But what you do incur is a storage cost penalty when you do that, because if you're moving from cold to hot, immediately you're going to pay those higher access costs for accessing the cold storage as you move it to hot. So even though you can move them around, it's best to aim to use the right tier of storage for your purpose. And if you look at cold, it's really intended for data that will remain cool for 30 days or more to be cost effective. Finally, we have archive storage as well. This has our lowest storage costs but our highest retrieval costs. When a blob is in archive storage, it is offline and so it cannot be read. And this is really because it's pushed off to tape or some other archive type storage that Microsoft uses on the back end. So if you decide you want to access something in archive storage, there is a period of time as that has to get rehydrated back so you can access it. Now, ultimately, just pick the right storage for your use case. And if you decide, okay, well, sometimes things go into hot storage and then eventually I want them to go to cold or eventually to archive, it is possible to enforce some auto tiering around this that will gradually move, unaccessed blobs from hot, down to cold, down to archive, and there's various automation techniques in Azure that allow this to take place. Finally, let's just take a look at the decision criteria as we try to choose between blobs, files, and disks. Often this gets very confusing. So if we break it down, blobs themselves, this is for storing large amounts of objects. Again, images, videos, etc. We might want to access them from anywhere. Just lots and lots of images, videos, text files, etc. that might be accessed. Then we've got files. So think of these as more from accessing from multiple machines, jump box scenarios. Maybe you've got a remote desktop that somebody wants to store a root user profile on. That's a good scenario. And then finally we have disks. So these are really associated with our virtual machines attached to the operating system. Think of this for like lift and shift scenarios when we're moving from on-premises. We might be doing disk expansion for application installations, lots and lots of read-writes. That's when we would ultimately use disks themselves. Now that concludes the overview, and I encourage you to check out the subsequent demo, especially as we kind of build blob storage accounts and move images around. You'll get a lot of feel for everything that we've covered thus far. In this demonstration, we're now going to cover creating a storage account via the Azure portal. So let's flip straight over to Azure. Here we are in Azure, and the first thing we're going to do is on the left, just go ahead and create a new resource group. So select resource groups, select add at the top, and type in your resource group name. So in my case, I'm going to use SL-storage. Choose your subscription and the resource group location. Again, this is just for metadata for the resource group itself. You can still put your storage account in any region you like. And go ahead and create that. The reason we do this and create our own resource group here is we can put all our storage accounts in there for demonstration purposes. Just delete the resource group when you're done and you've ultimately wiped everything out straight away. So within a few seconds that should be created if we hit refresh here. And there we go, SL-storage. Now we're going to that resource group, and let's go in here and create a new storage account. So go ahead and select add, type in storage account. You'll see it'll come up there, storage account, blob, file, table, queue, because that's what we can store in there. And go ahead and select that, create. And now we'll get the blade for creating our storage account. So first of all, let's go ahead and give it a name. So in my case, I'm going to use SL-storage demo. And as you can see, this is a publicly addressable namespace that we need here, so it has to be unique. Then we choose the deployment model. For everything in this course, we'll ultimately be using the resource manager model, as you've probably seen so far. And then we get onto the storage account type. So if we go ahead and hit the drop down here, we can see we have storage, storage v2, and blob storage. And ultimately now everything we do, we're going to use a storage v2 account. Now you notice some of the options change below. If we go back and choose storage gv1, we don't get that option for the tier straight away. I'm going to switch back to it again. And you can see that there we get a default access tier. And this is because we can set a tier of storage at the storage account level which will apply to all the objects underneath it. Now we can still change the individual blobs to have their own access tier, but this is quite a nice feature because we can say, okay, everything we want here, we might want cool, we might want hot. In my case, I'm going to choose hot, and everything underneath it will apply to. Then we can choose our performance. So we've got standard and premium, much like when we talked about virtual machine disks. We can choose SSD type storage or standard spinning disk. In our case here, we'll just go for standard for the purposes of this demo. Next, we need to look at replication options, and we have the same four that we covered in the virtual machine section. LRS, which is a locally redundant storage. This is 3 copies locally in the same data center. We have ZRS, which is zone redundant storage. This is in preview currently. Still 3 copies, but in a zone-based region, so a couple of data centers in the same region. Geo-redundant storage, which is GRS. This is 6 copies across multiple regions. And finally, RA-GRS, which is read access geo-redundant storage, that allows us to replicate to another region and actually read data there. It's basically warm and ready for us to access. In our case here, we'll simply select LRS. Next, we choose our access tier, as we already discussed. We're going to use the hot tier. And then we have options around secure transfer. If we open up the information on this one, this allows us to enforce encryption options for when we access in data from the storage account. For the purposes of this demo, we'll just choose disabled. Choose your subscription and select the resource group we just created previously. Finally, scroll down, select your location. In my case, I'm going to continue to use North Central US, and choose disabled for virtual networks. This option, which will be covered in the networking section, is around virtual service endpoints, and that allows us to say take a storage account, and instead of exposing it over the internet, we can expose it directly through a virtual network. And this is a way for security teams to buy off on the fact that, we have blob storage out there that's only inside of the Azure private network itself. With all those options selected, go ahead and click create, and then we'll fast forward here. It should take about a minute for your account to be created, and we'll transition to once that's completed. As you can see, after a period of time, the storage account is now created, and we can go ahead and select it. Once it opens up, you can see the performance that we chose, which is standard, the replication set to LRS, and our account, which is set to GPv2. And then at the bottom, you can see our various services. So we've got blobs, files, tables, queues. If we wanted to go ahead and upload blobs, we could go into the blob section, create our container, and upload it from here. But you'll see in a subsequent demo, as we use Storage Explorer, how you can upload lots of blob images and manage your storage account from there. And with that, this concludes this demonstration. Now we move on to a really exciting topic, which is IoT, also known as Internet of Things. And it seems like you can't move these days without hearing about another device that is connected to the internet that is sending data. And this ranges from everything from Nest cameras in your home, your refrigerator, but the industry ramifications are pretty important today, and Azure has a whole lot of IoT services to help support the industry. Whether you're a farmer out there trying to get more production out of your crops by having more data about, say, moisture and things like that, whether basically a car manufacturer or an insurance company for automobiles, and you want more data about the cars to maybe change the way you construct insurance policies. Lots of industry challenges and changes happening as a result of IoT. And if we go into a little bit more detail about what Azure IoT means, well, Azure IoT is a collection of Microsoft managed cloud services, and they're focused on connecting, monitoring, and controlling IoT assets. That's kind of the core of everything there. And if we get into that a little bit more, IoT solutions are made up of one or more IoT devices and one or more back-end services running in the cloud. So let's just look at some device examples first of all. We could have the water sensors for farming, it's a good example. We could have pressure sensors on a remote oil pump, and we could have things like temperature and humidity sensors in an air conditioning unit. All great examples of IoT devices that could be out in the field, sending data back. And ultimately, these IoT services in Azure are a place to send data back to. But let's break down those services a little bit more. Well, one, we have IoT Central. So this is a SaaS solution to help you connect and manage all your devices out there. That could be pushing updates out to them, just knowing where they are, asset management, things like that. It's really around just managing and connecting your devices there. Then we have IoT Hub, which is a core service a lot of customers use now. This is an underlying service needed to facilitate the messaging back and forth between your IoT application that's perhaps running in the cloud and the devices out in the field. And then we have IoT Solution Accelerators. These are complete, ready-to-deploy solutions that implement common IoT scenarios. And so for the exam for AZ900, you really just need to know how to describe IoT, understand what it is, where it fits in, to the picture as a whole. But you shouldn't be required to go into any more technical detail. You just need to know at a high level, what these services do. And you might get some questions around when to use which one, and maybe some scenarios about IoT out in the field. Okay, so we've covered everything from database services to generic storage services, and we still have one more category in data service to cover, which are big data solutions. And it helps to just understand, well, what is a big data solution to begin with? And I think this diagram from Microsoft really sums it up, very, very well. To begin with, we have data that needs to be ingested. This could come from all sorts of sources. This could be images, CRM tools, line of business applications, IoT that we talked about in the IoT section, and then ultimately gets ingested, and that could be through some data orchestration and monitoring. Microsoft has a tool called Azure Data Factory. There's other tools that are available, in the market as well, but ultimately they're ingesting that data in and then storing it somewhere in a big data store, basically. Once it's in that big data store, then we can use things like Hadoop, Spark, machine learning algorithms to prepare and train the data. And then when the data is ready for complex analysis, things like SQL Data Warehouse, use Polybase, which is a tool under the covers, to query the big data stores. And then Polybase uses standard, what they call TSQL queries, to bring the data into SQL Data Warehouse. And ultimately, all of this is to provide some apps and insights, on top of that data, to give some meaning to it and help the business make good decisions based on that data, or use it, for other purposes that they need it for. But ultimately, let's look at the different services available. Well, to begin with, we have the SQL Data Warehouse. This is a key component of the big data solution. This is a cloud-based enterprise data warehouse, EDW, that you might hear about, and it uses massive parallel processing, so it can run complex queries across petabytes of data. So think lots and lots of data here. It stores data in relational tables, reducing storage costs and improves performance. Then we've got HD Insight. So if we look at HD Insight, this is fully managed open source analytics services, for the enterprises, and it uses the most popular frameworks like Hadoop, Spark, Hive, etc. So some customers might say deploy Hadoop on premises, or may deploy it in the cloud on top of virtual machines. This is essentially a service that's created for you, to kind of take away some of the pain of setting that up yourself. It has some good scenarios. So we have batch processing. So this is the extract, transform, and load process, also known as ETL. So ETL stands for extract, transform, and load. And this is a process where unstructured or structured data is extracted from all those heterogeneous data sources. It's then transformed into a structured format and loaded into the data store. And you can use the transformed data for data science or data warehousing. If we look at data warehousing, this is where you can use HD Insight to perform queries at petabyte scales over that structured or unstructured data in any format. You can also build models, connecting them to BI tools such as Power BI. Then we have Data Lake Analytics, and this is an on-demand analytics job service that simplifies big data. Instead of deploying, configuring, and tuning all the hardware, you pay only for your job when it is running, and you write queries to transform your data and extract insights. You basically write those queries yourself, and then you pay on demand when they run and execute. And so that, in a nutshell, are the core big data services that you'll need to know about. I'd say the big thing here is just understand that ETL is extract, transform, and load, and then understand the different services available here and where they might fit. And so there is this kind of which service chart put together. It'll be available in the slides that accompany the course, and it basically says, if you want X, this is the service to use. So if you're looking for that elastic data warehouse with security, fully managed SQL Data Warehouse. If you're looking for fully managed Hadoop and Spark service, that's HD Insight. If you're looking for something to automate data movements, that's Data Factory, etc., etc. This is a good guide to just guide you through which service you might want to use. It's also important to understand a little bit about an exciting topic that's growing, which is machine learning, often used by a lot of data scientists today, and just really, really cool stuff happening in the industry today around machine learning. And you just need to know about the different services that ultimately come into play that you might need to choose between. Well, let's start with just Azure Machine Learning and what machine learning is to begin with. Well, machine learning, by definition, by Microsoft, is a data science technique that allows computers to use existing data to forecast future behaviors. Again, that data might come from one of these data services we talked about, and then forecast future behaviors, outcomes, and trends. By using machine learning, computers learn without being explicitly programmed, and that's the big difference. And so there are two major services that Microsoft really wants you to understand. One is Azure Machine Learning Service, provides a cloud-based environment that you can use to prep data, train, test, deploy, and manage. So when you think of machine learning, that flow of prep data, train the model, test it, deploy it, and manage it is really what comes into play, and then track your machine learning models that have been created. And it has a lot of automated machine learning and DevOps capabilities built into it. Now, if that's too much to handle and you don't want to sort of dive in at that level, there's also Machine Learning Studio. And if we look at Machine Learning Studio, this is a visual drag and drop workspace where you can build, test, and deploy machine learning solutions without needing to write code. And so it's more of a wizard-based machine learning approach. It uses pre-built and pre-configured machine learning algorithms and data handling modules, as well as a proprietary compute platform. And so that's the core of it. That's all we're going to cover at this point for machine learning. But really the key here is know, when does Machine Learning Studio come in? This is the more drag and drop visual workspace option, or Azure Machine Learning Service. And that's more if you want to, maybe a data scientist that really has models that you want to manage and train and prep, etc. based on that flow. That would be the solution that you would look to for that. Let's begin our journey now by looking at the Azure account hierarchy. And if you're in an enterprise, you will have something that is unique, which is an Azure Enterprise agreement. And so you actually have an additional portal that people just maybe swipe in their credit card won't actually have. And that's the Azure Enterprise portal. And that's available at ea.azure.com. And in that portal, you can actually go in and create various departments and then go ahead and create sub-accounts inside of your enterprise. But for a lot of people, you actually start with just the account section. If you're sort of just trying out this course to learn Azure, you've probably used a free trial or you've swiped your credit card, you will be at the account portal, which is at account.azure.com. And there's a billings and usage link on there, which takes you to the place where you set up your account in itself. And so you will go there to manage your account and your subscriptions underneath. Speaking of subscriptions, once you've created your subscription, you will then want to access the Azure portal to actually put resources inside of it. And you do that at portal.azure.com. So this might get a little bit confusing at first, but just remember, enterprise, we start at ea.azure.com. For my actual Azure account, where I'm going to put things in, I go to account.azure.com. And then for my actual subscriptions, once I've created my subscription in that account at account.azure.com, I go to portal.azure.com, which you'll see throughout all the demos is where we are when we're deploying resources. Following that, inside of subscriptions, I can deploy resource groups, which are essentially containers that I can put my resources in, and I can assign RBAC permissions to them, which you'll learn more about throughout the course. That's how we assign access. And finally, as I mentioned, in the resource group, we have our resources. So multiple layers there. They've also introduced the concept of management groups recently. That's not on the exam yet per se, but that allows you to sort of take your various subscriptions and group them together and group up policy, because what tends to happen in large organizations is, as you build lots and lots of subscriptions and resource groups, and you want to assign policy and make sure everybody gets the right rights in their various groups and subscriptions, it can get really, really confusing. So they have brought out management groups, which allows you to kind of group up subscriptions and assign the same permissions and policies to them as well. But for the most part, we'll definitely give you this document as one of the attachments in the course. So if you're just unsure where to go, these are the main links and should clear that up for you. If we go a little bit further and look at the account to subscription relationships, when we have our Azure Enterprise enrollment, we have one-to-many relationship with departments. So I can have many departments inside of my Azure EA, and I don't have to have any departments in there. It's just a way of organizing depending on the way your organization is set up. Within departments, then I can have one-to-many accounts, or I could just have one-to-many accounts to the enterprise enrollment to begin with if I didn't have departments. Following accounts, that's when I create my subscriptions themselves, and it always makes sense to have a plan for your subscription. So what you want to do is know when you're going to add a new subscription. Are you adding it because you have to completely separate out roles from a role-based access point of view? Or you add in subscriptions because perhaps you hit limits? Those are some of the reasons that you would add a new subscription. If we look at the enterprise hierarchy example in a little bit more detail, here's what it might look like. We have our enterprise enrollment, we have department A, B, and C. Maybe this is finance, HR, maybe IT is a general department as well inside of our EA. And then I can have sub-accounts. Maybe I have them for dev, for test, and then within there, I have various subscriptions that I want to manage and put resources in. If you want to see some common scenarios, it helps to look at the major three that Microsoft showcases. One is a functional example where you've got your enterprise at the top. We've got things like finance and IT as our functional departments there. And then we have account owners, and subscriptions in there you can see are based on projects within those specific departments. So production websites, project 1 test, project 1 dev. If we look at something a little bit more business division orientated, so again, I've got departments, but I've got like auto and aerospace now, as opposed to like very distinct finance and IT. So we've got business divisions within the enterprise that then perhaps my subscriptions below are based more on the applications themselves. And then another one that does come up a lot is actually geographic. We deal with a lot of global companies, and when we work with them, they have departments in North America, in Europe, in Asia, and then they'll typically separate out that way, then create accounts within there, and then the sub-projects as the subscriptions within those accounts. We break down the EA type of accounts for a moment, and we look along the top. We have enterprise admin, department admin, account owner, and potentially a service admin as well. And if we look at the enterprise admin, they have the ability to add other admins, other enterprise admins, department admins, and account owners. They can add and edit departments, and they can add or associate accounts to the enrollment themselves. Can they add subscriptions? Well, no, but they could add themselves as an account owner, and that account owner could then create subscriptions. So if we just quickly move over to the account owner column, you can see there that they can add service admins. They can't add departments, so they're not part of that. They don't have the ability to organize the EA, but they can add subscriptions as you get further down. So again, the account owner can't add more accounts inside the enterprise agreement, but they can add subscriptions. The enterprise admin can create accounts, and they could technically make themselves an account owner, and then they could create subscriptions, but by default you sort of have this delineation between enterprise admin and account admin as well. Now in between that, we again have that department admin. So if I'm using that model where I have departments, the enterprise admin could create some departments, and people in those departments could then create accounts, but only in their specific department. And so that's really, really key there. How much access do you want to give out? How much ability to create services do you want to give out to the departments? A lot of it is determined if you trust that department, if you think they have the ability to execute successfully in Azure. Hopefully they're taking training as well, but that's why they have these roles in place. All of them on the bottom, you can see, typically have the ability to view their usage and charges and view and remaining balances. Only the EA can really do that, because that's typically based off like an enterprise commitment that Microsoft sales team and the customer have made together. Let's begin our journey down domain services now by looking at the three major options you have available when you're trying to deal with authentication in Active Directory. To begin with, we have the new service that Microsoft released with Azure and Office 365, which is Azure AD, also known as AAD or Azure Active Directory. This is the primary mechanism now and should be your first choice generally when trying to develop any new services and use their authentication mechanism. If Azure AD is supported, that is the way of the future. Then we still have Active Directory domain services. This is where you might install a Windows Server 2016 or Windows Server 2012. You might already have one running on premises, and you do a DC promo on that server, and it sets up your directory service. So if you're in an enterprise, you probably used to log in on your laptop and you authenticate. You're authenticating against Active Directory when you do this. Then we've got Azure Active Directory Domain Services, AADDS. Now this is a little bit different. This is where we actually have a managed version of Active Directory domain services, and we'll go into all three of these in a little bit more detail, but it's very important to be clear about which one you're talking about whenever you're dealing with Active Directory services in Azure. So let's take a look at Azure Active Directory in a little bit more detail. Again, that's AAD and has the icon depicted on the right hand side. This is the modern AD service built directly for the cloud. It's often the same as your O365 directory. So if you have O365 already, you probably already have Azure AD and a tenant there. That's probably what you're going to use in your enterprise. You don't have to necessarily create a new directory service. It can sync with the on-premises directory service as well. And that's very important, as you'll see when we cover AD Connect Sync shortly. Then we've got Active Directory domain services. So again, this is a Windows server with Active Directory domain services role installed on it. This is legacy Active Directory since Windows 2000. It's your traditional Kerberos and LDAP functionality that you might need, and it's deployed on Windows OSs, usually on virtual machines. So, it can be still physical in some environments today, but for the most part, most people deploy it on a virtual machine. Then we go into Azure Active Directory Domain Services, AADDS. And this is a managed version of the predecessor we just looked at. So Active Directory Domain Services, if we want that fully managed for us, Microsoft will build that domain controller and maintain it. That's what Azure Active Directory Domain Services are. It allows you to consume domain services then without the need to patch and maintain domain controllers. So that's the single best benefit of this, is maintaining a whole directory services infrastructure can be quite a bit of work. Yeah, that's taken care of for you. The one thing to note, this does allow then domain join, group policy, LDAP, Kerberos, NTLM, all of that is supported. Again, you don't have to manage it, so this is especially good for people that aren't familiar with Active Directory domain services. They can simply go in and set up AADDS and get that functionality provided to them as a PaaS service in Azure. To begin our journey down identity, let's take a quick look at Azure AD as a whole. And you might have seen this image before, which you can find at the link below, where Microsoft has a pretty good write-up on Azure AD fundamentals. But to begin with, Azure AD is really becoming the center of the identity world. You can kind of see it there in the middle of the picture. On the left-hand side, we have on-premises, because people traditionally had Windows Server Active Directory, sometimes known as Active Directory Domain Services, on-premises, other directories and things that they may have historically used. A lot of those directories are on-premises, and now in the public cloud, SaaS-based world, we've got all these other solutions running out there, whether it's ServiceNow, Salesforce, etc. And, identity sprawl was just becoming a big problem. People had identities in their business, and then they had that same identity in another business. Take an example, when you onboard somebody from a customer and you create a new user for them, well, what if you could just trust the identity that they've already got and the authentication mechanisms that they're already using? And so Azure AD ultimately was a solution to that. How do we sync up with our identity on premises, as well as enable collaboration from a consumer and a business perspective with identities, with other businesses that we deal with and consumers that we deal with. And at the heart of it also is three things: simple connection, self-service, and single sign-on. In fact, if we look at the Azure AD features in a little bit more detail, aside from being that enterprise identity solution, that single identity to keep, users and groups and everything all in sync across your enterprise, that's point number one. Adding single sign-on provides the ability to have single sign-on to apps and services. We don't have to go sign on again and again every time we want to access something. If there's applications we access, we've been given permissions to access them. We've already signed in when we logged in with our laptop, and maybe we used some kind of Face ID and other authentication on top of just a password. That's kind of there for you. And then we've got multi-factor authentication, as I was kind of just alluding to there. It's one thing to have a password. That's something I know. What about something that I have? Maybe that's a cell phone where I get the text message and I can key in that code. Maybe it's some biometrics, things like that. That just enhances security. So when we think of single sign-on and multi-factor, they're both great things, because I've got multiple ways to authenticate, and then once I'm authenticated, I'm signed on, and now I can access all my apps and infrastructure services that I need. And finally, just that self-service empowerment to the users. Nothing more annoying than getting password reset calls day in, day out, We can empower users to do self-service password reset, but also empower them to, access the apps and the services they need. They can go to like a My Apps portal and request what they need. And so all of this comes together and is ultimately why Azure AD is so important, and particularly as it relates to Azure. You're using Azure AD potentially for Office 365 and other things already. When it comes to Azure, now we're able to use that same identity solution and give it permissions in the Azure world. And so you'll see in the upcoming demo, we'll create a new Azure AD tenant and then go from there, show you how to create users, groups, etc. Managing access is naturally one of the most important things in Azure. Given that there's so much infrastructure that we're putting out in the public cloud, we need to find a way to secure it and lock it down so only the right people can access it and have the appropriate rights. And the way we do that is using RBAC, also known as role-based access control. And in Azure, the way it works is we have Azure Active Directory, so we create our users, our apps, our groups. You saw in the previous module around service principals, we can give an app a permission set as well if we want to. And then we scope it, so we assign the apps, the users, the groups to specific objects in Azure with a specific role. And the way that works as well is there's a number of built-in roles in Azure. So for example, we have owner. This one has full access to all resources, and this also includes the right to delegate access to others. Then we have the contributor role, and similar to owner, the only difference being that it can't grant access to other people. So it has all the permissions in Azure. If you gave the contributor right to somebody in the subscription, they could still do everything in Azure, but they couldn't give new access out. Then we have the reader role, and this is often used by monitoring tools and other third-party tools like that as well, where they can view existing resources but cannot perform any actions. Perhaps you've got a managed service provider that just needs read access to your environment. That's where you might use the reader role for that. And then there's a whole host of other roles, and you can click the link here. In fact, we've got a summary on this page, and you can see there's a whole bunch of roles for things like automation operator, backup reader, etc. And so Microsoft has created this subset of roles to kind of match a lot of the things that you might do in your department. Virtual machine operators is a good example. You might just want to have a VM admin from an operations side, have a role on a specific resource group so they can manage those VMs. That's a great example there. But if you select this link, and you can see if you scroll down, we have all those roles listed out, and if you select one of them, we'll just select contributor, and it will show you all the various actions and not actions available for that role, which we will get into a little bit later on, but know that this page exists for you. The next thing is, how do we define how the roles work? And you may have seen briefly on that page, there's the concept of actions. So the roles include various actions that people can perform. Essentially, they define what type of operation you can perform on a resource type and what actions you cannot perform. So there's not actions and actions you're actually granted. Write enables you to perform put, post, patch, and delete operations on a resource. So think of it from a REST-based stance. You can make REST requests against the resource providers in Azure. If we've got write access, we can do all of these kind of updates and posts and etc. And read enables us to perform just get operations, so we can do any get operation against any of those resource providers. You can use PowerShell to get the latest roles, so they're certainly available on the Microsoft website, but I encourage you to know this command, which is get Azure RM role definition. You can simply type that in PowerShell against your subscription, and it will tell you all of the roles available to you there. Now, the resulting user rights is always a combination of the user plus the role. So just think of it in this context. We've got our user, we've got our role with its various actions, and the resulting rights obviously overlap somewhere in the middle there, depending on what you scoped for that particular user. Now, if none of the roles work for you in Azure from the built-in list, you can go ahead and create custom roles. And essentially, these are just roles with your own actions and not actions available to you. Each tenant can have up to 2,000 roles associated with it. Like I said, it uses the same actions and not actions, and you've still got assignable scopes that you need to define in the custom role. So as opposed to when we you'll see in the demonstration, assign a role to a specific area, when you define the custom role, which is a JSON template, you do give it an assignable scope as well. So this could be subscriptions, individual resources or resource groups that you'll allow this particular custom role to be assigned to. And if we look at one of these in Visual Studio Code, you can kind of see the layout that we have here. So on the top, we've got our name of our role. So I'm going to call this one, for example, Skylines VM Operators. We give it a description. So in this case, this one can monitor and restart virtual machines. And if you look through the actions, all of them come from the resource provider. So things like Microsoft.storage/star. So that's everything in Microsoft Storage. We've got read access. Everything in network, read access. Everything in compute, read access. And in addition, we're given the options to start and restart virtual machines in the compute section as well. Then you've got some others there like authorization, subscription read access, insights, alert rules and diagnostics, and support. And this is because, it's not just the virtual machine. We decided we wanted the user to be able to monitor as well, so they need these additional pieces. There's no not actions in this example, and you can see that concept there of the assignable scope. In this case, it's just a particular subscription that this role is allowed to be assigned to. So hopefully that gives you an overview of the roles in Azure, and I encourage you to kind of just put this in practice and do this in the upcoming demo. In this demonstration, we are now going to go about implementing role-based access in our Azure environment. So let's head over to the Azure portal. And in the portal, the first thing we need to do is go